Good afternoon, everyone. Thank you for joining the session with me. My name is Chang Shu. I'm a senior advisor at PSPC working on the cloud solutions for GC programs and services, including GC Docs, GC Case, GC Share, and GC Interop. Today, I'm going to share what we've been doing to facilitate the integration of on-premise systems with cloud applications. First, let's briefly review the new demands and challenges we are facing, and then why we think APIs are the connective tissue for digital services, followed by a case study to show how PaaS and SaaS applications can access on-premise data and business logic through APIs. At the end, a demonstration to show how it works. As we are moving into cloud, the application architecture is changing. On the left side, this is our traditional application deployment architecture, while our data and our systems are deployed in GC data centers, in GC perimeter. There are limited interactions across data centers over GC network, and those interactions are mainly through file transfers. As we are moving into cloud, on the right side, our systems and data are going to spread to cloud services and cloud-based data repositories, while the services is changing data using the standard HTTPS protocol over the internet. So how are we going to cope with a new application architecture? With all the changes on the application architecture, we have new demands on how applications interact with each other. For sure, there are different patterns for application interactions. But here, our scope is focused on the real-time transactional data exchange rather than bulk data transfer. There are a couple of new demands here. First, the applications need to talk to each other to exchange structured data through standard protocol like HTTP, HTTPS, rather than other protocols like FTP, SMTP. And second, the applications need to be loosely coupled to each other so that both of them can evolve independently. A data structure of application A shouldn't have any impact on the application B, which has a dependency on application A. Also, the applications need to support devices, which means the traditional front end might not work on new devices. Hence, we need to decouple the front end from back end so that we can come up with new front end to support modern devices. Last point, because HTTP is not reliable, so we need to define an architecture that allows data to be safely transmitted using internet with higher availability. And this is why APIs come into the spotlight and play a key role in application integration and interoperability. People are saying that APIs are the connective tissue for digital services. We all know that API is an acronym for Application Programming Interfaces. But over the years, the modern API has taken on some characteristics that make them extraordinarily valuable and useful. APIs provide a modern architecture for accessing business logic and business data within applications, services, and platforms. Modern APIs adhere to standard. Typically, it's HTTP, HTTPS, and REST. And APIs, they are developer-friendly, easily accessible, and understood broadly. They are treated more like products than code. And people are saying, today, API is a feature of your product, and tomorrow, API is your product. An API is a contract. There is a contract put in place to define the structure of the data, the HTTP verbs, and resource URIs to access resources. As long as a contract is remaining stable, It doesn't matter if the implementation is changed or not at the backend. An API also provides another layer of security, because each API communicates with small packets of data, sharing only what is necessary to share or to expose. By exposing data and business logic through APIs, applications of backend systems are no longer monolithic entities. New systems can interact with them via APIs, no matter where they are deployed, either on-premise or on cloud. The API endpoints become the new front end for application services, and we can create an ecosystem of applications around APIs. It's also easy to design device-friendly front-end web applications based on APIs to completely decouple the front end from the back end. This is also called as a headless architecture. A headless architecture makes it easy for application modernization because we can keep the current business logic unchanged so that we can save our investment. And we only need to refresh the front end. Here, let's go through a use case to see how we can use APIs to facilitate service interactions in a hybrid cloud model. While we have a new front-end application deployed on Azure Cloud, needs to access the data from a backend system on-premise. In reality, a hybrid cloud model could be expensive, but the migration to cloud is not a one-day task, and there are many scenarios where we need to slowly decompose the legacy monolithic applications and migrate them into cloud. In this use case, cloud acts as an extension to data center. We can leverage hybrid cloud to start the move without changing everything at once. This diagram illustrates how we implement this use case with necessary components and also with the security enablement. On the right side, the rectangle represents the GC parameter. In this use case, for the backend systems, we use a PSPC backend system named Departmental Directory Service, DDS for short, which is an in-house developer application to find organization and employee contact information. This application has exposed its functionalities through SOAP interfaces. Then we use a GC service bus to convert the SOAP interface into the RESTful APIs. GC service bus is operated by the PSPC GC interop. And the REST API exposed from the GC service bus, they are HTTP based, they are lighter and easier to understand and consumed. And this is an internal API. On the left side, we have a front-end application deployed as an Azure App Service, which is the PaaS service. Of course, AS also works, but PaaS is more easier to use. The front-end application goes through the API gateway and firewall to invoke the APIs exposed from the GC bus. A web application firewall adds an extra layer of security as well. We also use the Azure Active Directory to handle the user authentication by creating an application registration in Azure AD and enabling the Azure AD authentication in the app service. And with the implementation of DKIM, PSPC's corporate AD now is synchronized with Azure AD so that we just need to use our PSPC credential to sign in to access the app. The biggest challenge, as we can see, is the cloud ground connectivity, based on the security design patterns for SAS-based information system solutions published by TBS. Interoperability of GC cloud assets with departmental and GC enterprise applications can go through either a secure gateway or internet with certain security controls. Right now, we all know that with the SCAD initiatives, a secure gateway is under construction by creating a dedicated secure connection, which is the express route in the context of Azure, along with some other components such as GCCAP and GCTIP for endpoint security. Well, at the time of this presentation, SCAD is not yet deployed in PSPC. So currently, an API invocation from this application goes through the Azure firewall to reach an internet to reach the GC bus over internet in a secure way. The GC service bus uses a whitelist to control the inbound traffic, so only the traffic from the Azure firewall can access the API. For higher availability, there is a front-end load balancer, which distributes traffic between on-premise and Azure. We can further extend the use case into a SaaS environment. So what about a SaaS application needs to access on-premise resources? For example, a SharePoint client-side web part, or a Power App, or a Dynamics add-on needs to access the functionality of applications deployed in a hybrid cloud model. Again, the interoperability is achieved by using APIs. The on-prem data or business logic exposed by APIs can be further proxied on Azure, like AS or PaaS, managed by an API gateway secured by application firewall. Once we have a modern application in cloud, it's easy to integrate them with Microsoft Teams. Teams has been rolled out to many government departments, and it has quickly become the ultimate collaboration and teamwork application. An application can be integrated into Teams as a custom tab, a card, or a bot. Users can add, customize, and find everything they need in one place without the need to navigate to different places or to open different browser pages, which reduces the unnecessary context switch in our brain and enhance our focus and productivity. If Teams is deployed using the same Azure AD tenant, then we can further leverage Azure AD to single sign-on the applications deployed in the Azure subscription. Here is an example to show how we integrate an application into Teams as a custom tab, which accesses the on-premise data through APIs, without the need to use a corporate VPN, without the need to switch to another place to open the application. We can make Teams a personalized and integrated workspace. And also, we can access the application anywhere from any device. Next, I'd like to walk you through a demonstration. Let's take a look at the front-end web application named Profile Showcase. It's deployed as an Azure App Service. It's deployed from a container image, and the image is pulled from Azure Container Registry. And rather than coming up with its own login page for user authentication, here we can leverage the App Service authentication feature, which means that we can use the integrated Azure Active Directory to authenticate with user. And the configuration is very simple. We just need to turn it on and choose the action login with Azure Active Directory. On the Azure Active Directory, what we need to do is to create a new application registration so that we can register this application with Azure AD. And we can set the read-write access permission as well. So when we access the application, since we have configured to using Azure AD for authentication, so it will bring us to the corporate login page. I input my PSPC account. After the login, it redirects me back to the application's homepage. This application retrieves the PSPC employee and organization information from backend DDS system resides on-premise. DDS stands for Departmental Directory Service, which is an in-house developed legacy application. It uses a database to store the information, and it feeds information into GATS on a regular basis. By leveraging APIs, we can redesign the front end using modern web frameworks. In this new web front end, we can search a user in DDS. We can see PSPC org tree. We can search for people by location. And we also try to integrate GATS here, but unfortunately, with the recent changes in GATS API, this doesn't work anymore. So let's search something from DDS. After clicking the search button, an API request is sent to GC Service Bus, which calls the DDS service interface to gather data from the backend database in real time. As we can see that data has been retrieved and displayed here, which is matching the searching criteria. And we can further retrieve the more details information from the backend DDS. We can browse the org tree of PSPC. Every time when we try to expand a parent organization, an API request is sent to the backend system to retrieve all the children organization information from backend systems. All happen in real time. And with this new front-end web application, it also makes it easier to integrate this web application into Teams. It's worth to mention that Teams is not a hosting platform, which means that we have to host our apps somewhere, like in the Azure subscription or SharePoint Online Framework or Power Apps or Dynamics Online. To integrate the app into Teams, what we need to do is to create a manifest file. We can use App Studio manifest editor to create a manifest file. In the manifest file, we need to input some app details, like the name, description, and most important thing is to specify the app ID. This is the same application ID we use to register our app into the Azure AD directory. And we use that to enable to single sign-on our app from Teams. Since we're going to integrate this app as a custom tab, so we need to specify the tab's details. For here, we need to specify the hosting URL, the content URL, the website URL for this app. Once it's done, then we can start to package our app and upload it to Teams. To do that, we need the admin's permission to grant us with the privilege to upload a custom app into Teams. Once it's done, then we can access our app from apps. So here you see that we can see the same application displayed in Teams as a custom tab. And what we have done here is like, by integrating those custom apps into Teams, we extend the functionality of Teams. Then we can make Teams a personalized and integrated workspace for us. This is the end of my presentation and demonstration. Thank you for watching. Feel free to send me your questions and comments via email. Thank you.